All right, as we get started today, go ahead and take your homework out and turn your textbooks to page 251. Page 251, you did numbers 18 through 24. That section there at the bottom of page 251. Let's take a look at these review problems together. Again, didn't have anything to do with solid figures that we've been working on for the last little bit. It says number 18, Landon worked 46 hours, 15 minutes in 5 days last week. What was his average work time per day? Well, hopefully, since you have a total work time and the number of days, you simply divided the 46 hours, 15 minutes by 5. And you said 5 goes into 46, of course, 9 times. That leaves you with 1 hour left over. We're going to convert that into 60 minutes. And then, of course, add that onto the 15 minutes we already had, giving you 75 minutes. That you then divide by 5 to get 15 additional minutes. So 9 hours, 15 minutes average per day, which you might recall mentioning that 8 hours is standard for a work day. 40 hours would be standard for a work week. So clearly, Landon worked some overtime, getting time and a half, some things we talked about in our review exercises. Number 19 says the perimeter of a rectangle is 74 feet. The width of the rectangle is 14 feet. What's the length? Well, hopefully as you did this problem, you started with the perimeter formula of a rectangle. 2 times the length plus 2 times the width, or you might have said base and height instead of length and width. It uses the term lengths and widths though. The perimeter is 74. It tells us that the width is 14. And since it's asking for the length, I could either represent it X or I could just leave it as L for now. Should have multiplied the 2 times 14 to get 28 and then subtracted that 28 away from both sides to get, 46 is equal to 2L, and then divide both sides by 2 to find that the length would have been 23, that was feet? So 23 feet, your length. Hopefully, you did well on those first 2 word problems. As we look at number 20, we have what is a funny-looking pentagon thing. It asks you to find the area. Okay, so I've got a couple ways that I can see to break this thing down. You've got a shape something like this, so not perfectly drawn to scale. One way to break it down would be to drop a line straight down to make a triangle, drop a line straight down to make another triangle, where there's your height, there's your base, there's your base, there's your height. And then you also would end up with, is that a perfect square? 6 by 6. You get a perfect square with a side squares. You could do it that way. Another way you could do it, I was just noticing, that's the way I first saw to do it. I'm curious if possibly any of you thought to break this down by drawing one line across here, giving you a parallelogram and a trapezoid. So there's a couple of ways you could have broken it down. If this gives me fewer figures, it gives me that base of 8 and height of 3 for an area of 24 square units. Then it gives me a trapezoid with a base of still 8, a top base of 6, and a height of 3. And so for the area of the trapezoid, remember that's going to be 1/2 the height times the sum of the bases. Well, the half of 14 is 7. 3 and 7 gives 21 square units from the trapezoid. Add the 21 and 24 to get 45 square units for your area, which is your answer. Now again, if you saw fit to do it a different way, again, you may have seen fit to draw a couple of auxiliary lines and subdivide it into, like I said, the triangle and another triangle. Well, this square is 6 by 6, which is 36 square units. The triangle would have had a base of 2, a height of 6. 1/2 base times height, or half of 12, is 6 square units. This base was 6, and the height was only 1 square unit. Half of 6 times 1 is 3. You add 6, 36, and 3, and there again is your 45 square units. Number 21, pretty straightforward, except that you have 2 centimeters for each box. So while you look at your purple parallelogram, you say, well, that's a 5 base and a 5 height. It's actually 10 base, 10 height. So for the parallelogram, area base times height, if it's base 10, height 10, that's going to be 100 minus centimeters, right? Centimeters squared for the entire purple parallelogram. But if we're only finding the shaded region, of course, we have to subtract away that rectangle. And again, it looks like 4 by 3. Well, it's really 8 by 6 because each thing's 2. So 8 by 6 would be 48. We're going to subtract those 48 square centimeters or centimeters squared away, leaving us with a shaded region of 52 centimeters squared. So there are your answers for 20 and 21. Hopefully you did well on those problems also. For numbers 22 through 24, number 22, really straightforward. Combine your n's to get 5n, divide away the 5 to get n equals 8. Number 23, distribute on the right-hand side to get 24x negative 6. Put a positive 6 on both sides to get 24x equals 48. And when you divide by the 24, you will get x is equal to 2. And then for number 24, get rid of the little y. You can't combine them because they're on separate sides. The little y being the 2y, subtract 2y from both sides to get negative 1 equals y negative 9. Don't lose the negatives. Then when you put a positive 9 on both sides, you'll get y is equal to 8. Hopefully you did well on those. If you have any questions, certainly feel free to email those questions to me. Turn over now in your books to page 257. Let's take a look at the homework that did involve some three-dimensional figures. And we have some formulas that you needed to learn from yesterday's lesson for surface area and lateral surface area. You'll recall that we said the surface area of a figure is the total area of all the various surfaces put together. But for a prism, or even perhaps a pyramid, the lateral surface area excludes the area of the bases. So I used the example yesterday that in this classroom, if you're just taking the area of the walls, but not the ceiling and floor, for instance, for painting purposes, that would be lateral surface area. Number one, remember for the surface area of a rectangular prism, we would want to use this formula. 2 times the length and width, plus 2 times the length and height, plus 2 times the width and height. Not necessarily in those orders, right? Just doubling those various products of the different dimensions. For number one, then, you should have found the surface area to be 1,300 millimeters squared. 1,300 millimeters squared. Now, of course, we would take away the 2 length widths, since that would be the areas of the base and the top base. So this would give us the lateral surface area of the rectangular prism. That would have only equaled 900 millimeters squared for your answer there on number one. Number two, we had a funny looking tent figure, and at the end of the lesson yesterday, we looked at one of these tents and we said that really truly a tent kind of folds out into the base of the tent. The triangle front and back kind of fold back, and the sides of the tent could fold out so that you get 3 rectangles and 2 triangles. Now we said for the rectangle, you can tell on the picture that the length this way of each one of them is 100 feet. And it says that the height along the slant, which would be the width of each rectangle, is 40 feet. So each rectangle then has an area of 4,000 square feet. Well, there's 3 of them. 4,000 times 3 would give you 12,000 square feet. But that's only these parts. We still have the triangles. Well, remember, we said that this piece here is 40. But the actual height of the tent from floor to the apex of the ceiling, it says was, well, wait a second. Correction. It's not perfectly equilateral, the triangle's not. Pardon me. 2 triangles, or 2 rectangles are congruent. I just looked at it more closely. These are 40 by 100. This is a 52 by 100, so scratch that. We've got 4,000, sorry about that, 4,000 square feet here, 4,000 square feet here. This is actually a 52 by 100, which would give you 5,200 square feet, and each of the rectangles is 52 by a height of 30. So if each one is 52 by 30, again, half base times height, that would be a half of 52 times 30. Half of 52 is 26, times 30 is 780. square feet. So we've got a couple 780s, we've got a couple 4,000s, and we got a 5,200. Let's see, let's add that to get 8,000. That's 13,200. A pair of 780s is 1560, and I'm getting 14,760. And that is indeed the surface area of the 10. They didn't ask for lateral surface area. So 14,760 square feet or feet squared should have been your answer for number 2. Hopefully you got that one. That was a little bit more in-depth because you couldn't just rely on a formula. Number 3, we're looking at the surface area of the cube. And remember, a cube has 6 faces. Each face is a perfect square, so that's 6 squares. Well, instead of side squared, since it's 3-dimensional, we call that an edge. So 6 times edge squared. The edge is 10. 10 squared is 100. 100 times 6 is 600 square inches. You could have solved that in your head. Number 4, we're back to the same formulas we used on number 1. Should have found the surface area to be 181 kilometers squared, and the lateral surface area here on number 4 to be 93 kilometers squared. Number 5 is a square pyramid. So remember, for the square pyramid, here's the one the book gives you. I write mine a slightly different way. Their formula is 4 times a half BH. That's 4 triangles that all come together at a point, plus a squared base. The way I write my formula for the surface area, and either formula is fine, is I start with a squared base, and instead of 4 triangles, instead of the 4 times the half, I just say 2BH. Where we need to remember that this BH is the slant height in question. Well, the base here is a base of 12, so 12 by 12 is 144, plus 2 times 12 times the slant height of 18. And, oh goodness, that gives us 24, 432 plus the 144, so this would be the lateral surface area, by the way, the area of all of those triangles that come together at the point, plus the 144 would give us 576 meters squared. And yes, that is correct. Surface area 576 meters squared. Number 6, again, that 6e squared gives you your surface area, 121.5 square feet. And the lateral surface area, remember, ignores the top and bottom. It only looks at the sides. Well, of course, on a square, there are 4 sides. So you have a surface area, or lateral surface area, rather, of 4e squared. That would give you 81 square feet for your area there on number 6. Number 7, a couple of word problems on 7 and 8 said the mountains received 4 times the snow a nearby valley received. If the difference in snowfall was 21 inches, how much snow did the mountains get? Well, hopefully you recognize that there were 2 unknowns. We had mountains and we had valleys, or valley, I guess, singular. It says that the mountains received 4 times as much snowfall as the valley. So we would represent the mountains as 4x, and we would represent the valley as x. But we're not going to add them, right? Don't fall into that rut of saying, well, 4x plus x, well, it's 5x. Careful, the difference in snowfall. So hopefully you recognize we're going to need to subtract 4x minus x to get 3x equals the 21. Of course, x is going to equal 7 inches. So the valley received 7 inches of snowfall, and the mountains 28 inches. Now, of course, the snow, when it melts, will all run down into the valley anyway, but as far as where the snow actually fell, 28 inches on the mountains is your answer for 7. Hopefully you got that. And then for number 8 says it takes Jackie 5 minutes, more than 1/3 the time it takes her sister Rachel to do the dishes. Jackie can do the dishes in 15 minutes. How long does it take Rachel? A basic approach, if we're just staying with that same method, is you got 2 people, right? Jackie, Rachel, and it says that Jackie takes 5 minutes more than 1/3 the time it takes Rachel. So Rachel would be x. Jackie would be 5 minutes more than 1/3 the time of Rachel. So a third x plus 5. But then it comes out and says Jackie takes 15 minutes. So Jackie's not really an unknown. Jackie's just 15. And since we have one unknown represented 2 different ways, our equation will simply be those 2 ways equal to each other. It's been a little while since we've seen one like this. Hopefully that's a good refresher for you. Here, we would put a -5 on both sides to get 10 is equal to a third x. We could represent, by the way, this as x over 3, remember. And if you were to multiply both sides by 3, that would cancel with the divided by 3 to get x is equal to 30 minutes. Apparently, it takes Rachel 30 minutes to do the dishes. We could check, is that 5 more than a third? Well, what is a third of 30? Of course, that's 10 plus 5 would be 15. So it does check out. The last problem on this part of the homework was number 9, finding the area of the shaded region. Now this one's kind of cool because it's not a polygon. It's a bubbly sort of thing. But hopefully you notice that essentially what you've got going on here is a square with a semicircle, a semicircle, a semicircle, and a semicircle. Well, that's 1, 2, 3, 4 semi or half circles. Well, that would mean 2 whole circles, right? And since it didn't have a scale on here, so apparently every box is 1. Since all of these sides are 3, apparently the diameter is 3. And the area, remember, of the circle is pi r squared. Well, if the diameter is 3, the radius is 1.5. So we're going to have to square the 1.5 to get 2.25, multiply that by 3.14, and that would give us the area of this circle. But if you then multiply that by 2, you would get the area of both circles. I'm going to start with 2 times 2.25 to get 4.5, because that minimizes the number of decimal places. Multiply there to get 14.130 or 14.13. That's just the semicircles added together. We still have to take care of the square, which is a 3 by 3 square, which is 9 more square units. Gives us approximately 23.13 square units. Now, I'll acknowledge some of these homework problems are a little bit more challenging than some of the other ones we've done. I'm curious to know how you did. So please email me over the weekend or this evening. Let me know, how did you do? And if there's a problem that you struggled with, first of all, go back and rewatch the part of the video where I explain it. But if it's still like, I don't really quite get it, shoot me an email as well, and I may go over that problem before we start the video lesson on Monday. But hopefully you did well with that. All right. We're going to go ahead and have you do a classwork assignment before the video proceeds. So if you would turn back in your book, or look across the page rather, to page 256. Page 256, and there's a short review section. The bottom of page 256 to the top of page 257, numbers 9 through 12. So pages 256 to 257, work on numbers 9 through 12, take just a few minutes, and we'll look at these answers in our next part of the video.